go back to this. So last time we were able to create this structure over here called struct vector. Okay, we created this CC structure, which sort of housed our array called data here. And we had this item called size, which is basically the capacity of the array. Well, we could rename this actually to, and call it capacity if it's a mostly, which is basically the name that you'd like to have it. And here, maybe we can even change this and call it number of items if it will make sense, right? If it will make sense to have these items named this way. So we have the capacity, which is the total capacity of the array, number of items in the array at any single point. Okay, at any single point. So we can sort of make that clarification for it up here. We have then used the type def facility to sort of create a synonym for the struct vector, and we call it vector, capitals, right? And then we created these items. This function, we said add items to the array. Let's call it push items to the array. And just to make sure that we're sort of pushing items to the array instead of saying we are adding items, right? Either way, it will be correct. Okay, push items. And this other function was called print items. Okay, both of these functions were receiving a pointer to the vector, and then working on it to change the things. Okay, now there are a couple of caveats to a lot of things. One of them is because this function is a void function. Basically, it's a function that does not return anything. It's a non-value returning function. Normally, if a function is a non-value returning function, then we want, okay, to pass by reference. Okay, we want to pass by reference. Now, so here it might appear that we are passing by reference because we are passing a pointer. But because the way the pointer has been declared in main, the item here as a pointer itself, then passing by reference, strictly speaking, means we would pass the address. We would pass the address of this vector, which basically means in here would then have something like this. Okay, would have something like that. Does it make sense? Okay, so passing by reference strictly means that we would have something like this. So let me show you how then that would work. So if we wanted to print items, then would then come here and we could declare something like vector, okay, p vector, a pointer, p vector, okay, or rather maybe so I don't end up changing too much code, I can do that. And I can say pvec of my pointer is, now we typecast this vector, this p vector here, to be just a normal, just one vector. Okay, so we can do that, and then we'll just do here like this. So we would change the past vector, would basically change it to a normal vector. So this was something that p vector is a variable that is storing an address of another vector that stores an address to vector. That's what it means. Okay, so when we call this, let me save this. Okay, so when we call this in our vector here, when we are printing items, then strictly speaking, we'll be passing the address of p vector. Okay, now what that would mean then is in our vector.h, we'd want to then change this to print items like this, and we can then pass it the way we are passing here. Now, I'll save this, and then we'll call this here. Okay, let's try to go back to that. So this is my desktop somewhere, COM 1020, and this is SP21, and then this is vector 203. No, 204. Okay. And this is where our files are. So remember, we use GCC wall to compile these vector.c, vector.c, and we had main like that. We try running this, okay. So we need to, we change add items and we call it push items, right? This is what happened. We had instead of add item, this class is called now push items. So we want to go to where push items is here, okay, and paste this so that we can change that push items, and we can go here. We no longer have add items, we have push items. We can save these things, save, go to this one, save it, and we go to this one and save it. So everything is saved. We try now running it, okay. No member size in struct vector, pick vector size. Okay, again, we changed a couple of things. Sorry, we'll have to go back and change a couple of things, but it's setting a good foundation, so there's no problem with it. We had, we renamed this to capacity and this to number of items, remember? So we named this to capacity and number of items. So we want to change that. So let's see. Okay, so I think capacity, is it size and capacity? Yeah, size and capacity. So let's look for them. We find all and replace all, so that it's up here. And I think also we had items, and we call that number of items like this. So we want to find them all and replace them if they are there. I think that works. We can go back in here. I think this was the only one. Okay, so we can do the same. To find all and sorry, replace all. Okay, and size here was named size, and then capacity, and we can do the same. We can find all and replace all if they are there. Okay, so that should be able to solve all our problems, and we can save this. Save this. All right, save everything, and then we run it again. So now there's no problem, okay? And if we do this, we'll list all the files we have. You can see the a.out, which says Kitable, and we can try running it, and it will give us the things that we had before, okay? All the items that have been added before. So we have not done anything much at all, really. We have just basically renamed our function. We call it push items, and then we sort of renamed these member variables. Where are they? Member variables here, one to capacity, the other one to the number of items, with the idea that we want to make our variable names to reflect our knowledge and to reflect how we understand what these things are doing. So far, so good? Okay, good. So that's all. And everybody can remember this, so this is awesome. One other thing I want to mention about is, remember here we included this vector.h. Actually, here in main, we can remove this because we already are including it. So I'll save this, no problem. So our two files, stdlib.h, stdio.h, all of them have been included in our .h file. So that is good. And then we are including the .h file in here in the implementation, and also in our main, we're including the .h file. So who can tell me, when we include a file, for example, when we do include vector.h or include stdlib.h, what really happens? Like during the linking stages of the process for compilation, what really happens? So for instance, what do you think would happen if I included this file twice? For example, say I included this file twice, what would happen? Right, so let's try. If I did this and I put it like that, okay, it says, well, unguarded header. So it's giving me some information here. It says unguarded header, redefinition of vector. Okay, it's saying that these things are being redefined. Okay, it's saying it's being redefined because I'm adding this twice. And then it tells me, consider using if def guards or pragma once guards to guard this. So what basically is happening is that we can use these preprocessor directives like pragma once, which tells us include this file only once. Okay, so we could go into this file here, and on the top we can add pragma pragma once like this. And so if we add that and we save it, then when we run it now, it doesn't give us those problems. See, we still have it included twice, but we are not getting any particular problem. So that preprocessor directive is basically instructing the compiler to only include this file once. Does it make sense? Okay, so that's good. Another thing that we could add, another thing that we could actually put instead of pragma once, we can use what is called conditional preprocessor directives. They work like this. Instead of saying pragma once, we can say if not defined, if not defined, then we define this file, the entire code in the file as a macro. Remember, to define a macro, we have been using the defined keyword like this. So we would say, let me give you an example. For example, we can define max to be 100. What that means is whenever we see this word max, it will return us 100, right? So we are saying we are going to have this max to represent this constant 100, right? So we could do that for actually an entire block of code. So for example, we could say define max, and then we don't put any value here, and max will be all these files here. So everything that comes after the max would become part of, of what is called max. So how people then use these facilities is that we can create something like this. We can say that this code here is going to be called vector. So I can say define vector, let me call it vector H, like this. So that vector H is the inclusion of all these files of things that fall in here. But so because we are defining it, we can say if it has not been defined, if not defined, vector H, if it has not been defined, then define it. All right. And then once we are done defining it, we can say add if here. So these are called conditional preprocessor directives. This is an if preprocessor directive. Okay. Does it make sense? So you could add that, and that by itself, if we went back to our code and try running it, it should work still pretty fine, where we have included the file twice. So that guards this kind of errors that could occur by us including this file, because if you are calling multiple files that all have dependencies, then it's possible, to try to include the same file more than once in different multiple files, right? So in order to guard against having some errors, then for that particular file that we think the problems can occur, then we can sort of guard it with this define if condition or even pragma once. So far so good? Okay, so I wanted to mention that as one thing that occurs when you're working with multiple files and how to sort of protect yourself from getting those errors. Okay, let's go back. So that has been done. So we understand that. Well, we don't need it. I can remove this. Still works fine. Okay, and we have our files in here, and we have seen how the print items works. I added that. Remember, for push items, I could also do the exact thing by adding another asterisk. Moral of the story here is, if we have a function which is a non-value returning function, then we want to pass by reference. You learned that when you did the introductory class, right? You want to pass by reference. If your variable, the one that has been declared, If the variable is already a pointer, really technically then it means that you're really not passing by reference if you're just passing the pointer. So then you want to pass the address of that pointer to be able to say I'm passing by reference. Okay, so in that case, this is what is required for it. It's the same thing that's required for push items. We're not going to worry about that for now. Okay, so there are a couple of things that we did. So we were freeing this. We cut this. We did not cut this error. You know, when we malloc here, we tried catching the error that would be associated with the malloc returning null. We did for this one. We did not do for the first one. So to make this code look better, we could do that as well. Okay, so we could say if p vector is null, then print null memory and exit. But technically speaking, this is what we are doing. The first malloc, this malloc, is creating for us. Remember when we declared p vector, let me actually, let me do this. Okay. So here we made a variable, okay? Pointer to an instance, rather, to an instance of a vector, okay? So this is a pointer to an instance of a vector, and this is the variable that we'll be working on. And technically speaking, this p vector is somewhere in the stack, so p vector is here, and because p vector is a pointer that can keep an address of a vector, we need to populate it with an address. So initially we can just start by, well, initially we can start by saying our p vector is pointing to null. So we could do something like that. P vector equal to null. It's not keeping an address, right? So if we were to draw this to say something, it's like supposing null was supposing null was something like us crowding, right? We could point to that. So pointer right now, our p vector, by assigning to null, it looks like this. Then when we call this malloc, so we are asking the memory manager to go to the heap and allocate us enough memory bytes to store, you know, a vector. And our vector has 12 bytes from what we saw last time. So the memory goes to malloc and assigns us a memory block enough to store a vector. So here is what we are calling a pointer to data. This is our capacity, and this is our number of items. Okay, that's what's happening. So if malloc does not return null, it basically has assigned that, and the assignment here means that if the address of here is A21, for example, that A21 is being saved up here as A21. So that's what really people can say that is pointing. It's pointing because we are just doing that. Okay, so it's no longer now null, is now pointing to this memory block. This here, if p vector is null, if basically malloc did not return for us a memory address and it was null, then we could exit here. Now, then what we have done is the capacity now is initialized with a 7. So we are putting a 7 in here, and the number of items is being asked as 0 because we don't have any items in the array at this moment in time. Remember, the most important thing we are doing is we want to keep our data in the array here. That's where we want to save our data. But we need these two things, the capacity of the array and the number of items at any single point in the array to be able to work with that array. Okay? Now, that's what we want to do. All right? So then what we do now, because we have the capacity, we can again go to the heap and check for enough memory that can handle the number of items that we want to start off with, 7 in this particular case. So that's what this malloc is doing. And basically it means go to the memory. Remember what we said before? The assignment operator has a right to left association, meaning that this part is going to be executed first. So go there, call malloc. Malloc is called, and malloc possibly is able to find a block big enough to store 7 items. So if an integer is stored in 4 bytes, so 4 multiplied by 7 is 28 bytes. So this would be, say, 28 bytes. So initially, this P data is not pointing to anything, right? Let's assume it's pointing to null. So to start off, it's not pointing to anything. Then now, by doing the assignment, if this address here is maybe address A30, now that address is basically being kept by our pointer A30. Remember, the name of the array is a pointer to the first element of the array. So this address of the first block is basically being kept up here. So I have questions for you. If this malloc here in line 26, if this malloc returned null, if this malloc had returned null, this block here, would we need this guy here? Would we need this memory up here? Let me ask that question in another way. If we did not have this block, let me get a blue pen. If we did not have this block, would we need this block, the first one? This first block, this is the second block. If we did not have the second block, would we need the first block? Bill says yes. Why is it? Why yes? Louis says yes. Hirutesh says yes. Okay, tell me, if we did not have the second block, would we need the first block? Let me hear your reasoning. You can write it up on the chat. Someone? So remember, I think we need the first block to hold the original data so that it's not lost. I agree with you. So the question is, Jayla, that now that you say that, if we do not get the memory here, I want you to think back about how you defined a vector to be. If we are not able to allocate memory for the array, if we do not have the array, would we need the structure? If basically we are not able to make the array, would we need the structure? So first question, where does the structure, where does it exist to start with? What is the main point of us creating this structure? I think the overwhelming idea, well, to hold variables, but which variables is most important here? What are we working on? What is our data structure really here? What is our data structure? Remember our data structure, okay, is this container that we are able to put our data in. Is this container that we're able to put our data in. So we are keeping our data in the array. So if we do not have the array, do we need the structure? No, we don't need it. That's correct. If the array is the most important item here, we are keeping our data in the array. So if we do not have this memory here, we might as well not have the other memory, because if we are not able to keep the array, why then do we have the structure? There's no point. So what we can then do, we can change our code to say, if p vector data is null, if the array cannot be created, we can print no memory for the array. Maybe I can say this, no memory for the array. And then we can free the memory block, the one for the structure, we can free it and possibly then assign our p vector back to null, like how we had started off the day. Right? We started off the day with p vector pointing to null. Well, freeing would still assign it to null, but we are being very explicit here and saying that it's going to be assigned to null, just in case there are any problems. Okay, and well, we can exit the code if we want to exit the code. We might not necessarily need to exit the code. We can exit the code if you want to exit the code. I'll just remove this for now. Does it make sense? So what I've added here is these three lines, line 30 and line 31, that, well, if we are not able to create the array, if we are not able to create the array is the most important thing. Look what we say in a maybe almost layman's way, but again not layman's way. We say we are creating this vector as a concept, basically to mask the dynamic array, the implementation of the dynamic array. So the dynamic array is the most important thing here, right? Does it make sense? The most important here is that dynamic array that we have. We want to work with the dynamic array. So if we do not have the memory for the dynamic array, then where do we have the structure to start with? So that's what we are doing here. I'm freeing that p vector. Okay, and that's all good, right? Correct? Awesome. Now let's go on. So, and then now we call it push items, which basically added our items together. We printed those items again. We freed the memory for the data. Again, understand this for sure, that our pointer looks like this, a p vector. It's basically keeping an address for something which is the heap. This thing is the vector here, the vector item here. So this has the data, which is the array, rather. It has the array. I call it data because it's keeping the data for us, you know, so that there's no confusion. Then we have capacity, and then we have number of items in here. And so the first malloc created this. The second malloc created this, basically the array of whatever number of items that we have. Let me take a red pen and say, so if the address starting here is A21 and the address here is B10, then A21 is being kept here and B10 is being kept here. Do you see that? So because these are pointers, so the array is a pointer, right? So we have a pointer basically here mimicking the implementation for an array. And then we have the p vector up here. Okay? So that's basically what is happening. Now, so that's what they do. So when we are freeing it, when we come now to releasing the memory, when we are coming now to release the memory, remember we cannot, if we release this memory here, if we start by releasing this memory here, then there's no way to go to here. See, we must, the way now the line is going, the order of operation is we move from p vector, let me get a pen, we move from p vector here, we go to the data in order to go here. See, so if we wanted to release the memory, then it will be the reverse, right? Releasing the memory will be the reverse. Does it make sense? So we need to release this memory first before we can release this one. And that's what this code is doing. Free p vector data and then free p vector. All right. So far, so good? All right. Couple of things we could do. Remember all this stuff here, we are doing them, we are making all this work inside of our main. And remember, we don't want to clutter our main. We want our main to be a driver. You know, we want our main to be the driver, that its work is to call all the other functions and to make them operate. So one of the things we could do, we could remove these here, all this information here, and put it in a main, in its own independent function. Okay? If we created such a function, what do you think it should return? If we created such a function, what do you think it should return?
Null.
Null? Well, if we create a function that creates all these things for us, what kind of things would it return? Remember, the function is creating a vector and all the components. Well, Jaira says a type of vector. I agree with you, Jaira. It should create a type of vector because that's what it's creating. Okay, so supposing, well, because it's going to be a pointer, because it's going to be a pointer, so it should return a pointer to vector, because that's the exact thing that we want to work with. So we could do this. Let me create it up here. Remember, we're going to move it to where our things are. So vector, like that. And then we can call this function. What do you want to call this function? Somebody? So what is the purpose of this function? What is it doing? It's returning a vector. And it's returning a vector by it's making our initialization. So it's creating the vector for us, creating the memory needed for the array, and initializing these variables, capacity and items, right? So its work really is to initialize for us what our vector type will look like. So I'll call it this vector. So I'll call it this as an initializer, right? So this function is an initializer. Let's call it vector initializer. Maybe initialize things by default. It's not going to receive anything. Vector init default. So this function is basically not. It's going to return for us an initialized vector, a pointer to us. That's what it's going to return back, and it's not going to receive anything because, well, it doesn't need to receive anything. We could pass our initial items 7 and 0 and anything else we need to this one, but for now we don't need to do that. So I can copy this, I'll paste it here. I just want to do it in the normal way that we have been doing things so that you can understand it fast. Well, if it's not getting anything, let's make it explicit that it does not receive any items. So it's void like that. And what we're just going to do is we are going to copy this, the whole thing like that. In fact, I just can cut it like that, and I'm going to paste it here. And now look, so it should be returning for us the p vector, right? It should be returning for us p vector because that p vector return p vector here, because this p vector that's returning is what we made here. So it's returning a type of vector. P vector is a pointer to a vector. We need it to be returning a pointer to a vector. It's going to be returning it. We already made it. So it's going to be returning it back. So here we can create something here, vector, vector here, and we can call it anything we want. Maybe you can call it pointer to vector, or something. Or because itself is not really the vector is being made in here. The vector is made in here. We can call this maybe a handle to the vector. Okay, for now, don't worry about it. Let's just call it p vector. Okay. And what we can do is our p vector now, p vector is equals to get this init default. So now, instead of so we can start with this being null, p vector being null, and then we assign it. But instead of assigning it the way we were doing before, where all the code was here, we can now call this function vector init default that will do that job for us. All right, so let's save this. And I'm going to try to code with it. Again, we call it. Okay, it's saying that it's returning an error here. And we create p vector. Did you mean p error? Did we have p vector somewhere? P vector data, p vector init default. Oh, sorry. This is vector capital. Sorry, that's the where the error is. P vector capital there. Okay, so no problem. We do that. Okay, it runs no problem. We can run it again. A dot out. Okay, that's the same job it was doing before. So remember, we have not added anything, and I want to break this to very simple way of just thinking about it. We started by just coding it, right? And we are moving slowly towards creating this wonderful product, right? So now, instead of our main declaring our memory for us, we are able to do this. And you know what? We could copy this guy, cut it, paste it upon here, and we can go back, sorry, and we can copy this code, cut it, and we can paste it here. You can save this. You can save this. Now, look, our main is very it's not cluttered at all, right? Because we have these functions that's doing the work for us. We are creating what is called modules of code, right? Modules of code. Each of these modules is a function that is doing a particular task that we need done, right? So for example, we have one now that is going to create the memory for us and initialize all the variables that we need. We have one that's adding items, and we have one that's printing items. The other thing we can do, even freeing them, we can sort of free these things because, well, why have it here if we are initializing it up there, right? So we can create another one. So this one is not going to return anything. It's going to be non-value returning function, void. What do you want to call it? One of them was initializing. The other one, what should we call it? Freeing. Oh yeah, we can even call it destroy, right? Because it's destroying the memory, right? Destroying the memory. Remember, because it's a non-value, because this is a sort of a non-value returning function, it's a non-value returning function, then we must pass by reference, right? Correct? So we want to get vector. Maybe we just call it pvec, for example. So it's going to get the address of an address, right? So we copy this guy. Again, we're going to do the same thing. Copy, paste it here, write the code. Now, the code is really this. You can just copy and paste here. But because we are using this idea here, because we are using this idea of passing by reference, we are passing a pointer by reference, meaning we are passing the address. We are passing the address of the vector, meaning we are doing this. Why is it? When we call this function destroy, it will be similar to how we call print items. So we'll be passing an address of p vector. This is what pass by reference actually means. So if you're passing a pointer by reference. So because we are doing that, in order to work with p vector like this, we are going to say vector, we create a pointer, p vector. Now we typecast whatever was passed to a vector type. So just one star, and then star. Remember, we dereference now, because remember, if we dereference pvec, we'll get the pointer that we are looking for. Okay, so we dereference here to get the actual pointer that we need, and then we can just do this. So this will say it can return, because it's a non-value returning function, so we can have an empty return. What are the other things actually we could do here? We can say only free if we need to free. So we could say if p vector itself, is not equal to null. If p vector is not equal to null, then basically free the things inside the vector, right? Then free p vector data, and then free p vector, and then make p vector equal to null, so that it meets the first condition that we set it to be. So we can make this function look cool by just doing this. So number one, we have passed this by reference. We have typecasted this to the type, the known type that we have, which is the vector. And we are saying if p vector is not null, basically if is pointing to some stuff, then free the data, the pointer to the array, free the p vector, and just make sure that it assigns to null. Again, we can just copy this and we can paste it here. Let me paste it to the end so that it follows like the sort of line of data that we have. And save that. And we can get this code over here, cut it, and we can also paste it here. Okay, so we're going to save this. We will save this. You can save everything that we need to save. Okay, everything has been saved. So that's good. Now let's run this code and see whether it works. Okay. It's complaining about struct vector, vector. Oh, sorry, I mistyped it and I wrote vector. I wrote vector. So let's go and check that. Where is it? Here, vector. We want it to be like that. Vector, I think that's what it's called. And in the, okay, even here is vector. And we can save this. Right, and then we can try that. Okay, I think again we have, oh, vector. Oh, where is it? I didn't save that one. Okay, I think I didn't save this one. No, that was saved. I think that's saved. That's saved. Did I call it in the C vector? No. Okay, let's see where it's complaining from. Destroy. Destroy. We have changed it, so maybe we have not saved it properly there. Okay, I think this one. Okay, possibly this one. Yeah, saved it. All right, let's run it. It's complaining. What is it? Unknown type name vector. You mean vector? Type def struct vector. This was in which file? In main. Okay, so let's go to main. And we want to remove this because anyway, we added it somewhere else, so it should be fine. Okay, good. At least we can follow this and be able to do it next year. Okay. No expected identifier. No. Let me check. Okay, sorry. I think here p vector is equals to null. Sorry, that's what we meant. P vector is equals to null. So we won't want to do that. Okay, so runs no problem. A dot out work the same. So far, so good. Do we have questions? I've tried to take this journey to creating this. Remember, our vector is not just the this item here, not just this struct, but there are also some behaviors that's going with it, right? There's also some behaviors that's going with it. So the masking of this dynamic array implementation is just the implementation in terms of the array itself. It's also the functions that helps us work with this array. Does it make sense? It's also the functions that helps us work with this array. And for example, creating memory, that's important. Freeing the memory, that's important. Maybe printing the items already held is important. Adding items is important. We still have not, so one of the things, for example, right now we are not really pushing items into the array. We are just creating items randomly, right? We are just creating items randomly into this array. We could add items one by one, and we can create that in a few minutes. But do we feel confident so far as we build this? Do you feel confident so far as we do this? All right. So, well, okay. Why don't we change this guy here instead of him? Instead of now pushing items, doing whatever it's doing. Basically, we are putting all items together. at the same time. So we want to add items one by one, something like this. Somebody will pass an item into item like this, and then we add that item. So in here, we just need to add the item like that. So, well, that is easy. Instead of saying while, because while will keep iterating, we just say if. If the array, okay, if pvec number of items is less, maybe you can say, yeah, if it's less than pvec capacity, if it's empty, then add the items, right? So we can just change the code easily as that. And we can save this. So now we'll be adding items one by one. And we can come to our vector.h here. Okay. And we can do int items. So this will add the items one by one, like that. To add the items one by one, just by doing that. And let's see whether it works. We go to main, but now instead of pushing items, just one of them, we can push a 7. Let's add like 3 items or something. Something like this. Actually, let's put 18 here or 28. So that's more distinctive. Okay, so let's run this. Run it, no problem. A dot out. Okay, now it's only 2 items, 7 and 28, because we are adding those items in here. And we can keep doing that. For example, we can add as many items as we want. Remember, what we are interested in doing is creating a data structure, right? Is creating a data structure. And therefore, creating a data structure here means we are we want to be adding items, not randomly, not from anywhere, but we want to add items whenever there is a need to add an item to our structure. That's what we are interested in. We want to add our items into the array. So let's see how this works. Again, we compile, no problem, a dot out, and it's able to add the items that we need, one by one. So remember, important thing that we discussed here, the concept, the vector that we are creating, right, is able to mask the implementation of a dynamic array. So the array must grow, right? Right now it's not growing, correct? Right now, our array is not growing. I mean, if this how many items? 1, 2, 3, 4, 5, 6. If I put more items, maybe 3 more. So if we add 3 more items, 7, 2, 8, maybe 2, 7, 8. Is it 3 more items? 1, 2, 3, 4, 5, 6, 7. So it's you've added just 1 more item. Okay, these are the additional ones. Okay, if we have more additional items, how many items can the array hold? That does not change. A dot out. Okay, the array can only hold 7 items, right? Remember, that's what we define the size here to be. It can only hold 7 items. So what we want to do is build a dynamic structure or a dynamic array that's able to maybe double the amount of memory as we go on, right? As we add items. So that's what we are going to do when we meet on Thursday. We are going now to make our array to be able to resize and increase the memory. But important for now, and important for this code that we are building up, you have been able to see how we can create a function that basically allocates memory for us and initializes the variable. If you ever programmed in a language like C++ or Java, right? Or Java, or even Python, this is a constructor. This function is what is called a constructor. Okay, this is a function. This is the function called constructor in object-oriented programming. But see, it's not object-oriented programming, so we are creating our own functions like this. Okay, so we are making it a constructor. It's creating the memory for us, and then initializing our variables. This function here in those languages, Java, C++, C#, whatever, is called a destructor, because it's freeing up the memory. Also, we are calling it the same sort of names. We are calling it the same sort of names, so that when you go to a class that teaches you those things, again, this is not going to be a foreign language for you. All right, so I'm going to add there. Remember that this video is going to be available on my channel on YouTube, which you already have, and it's also going to be available on recordings at a Zoom, so you can be able to go there and view it again. Please practice. That's the only way we become perfect. All the best, everybody.